Hello student, I am Arnab Das. Today we discuss about the Hamming code. Hamming code are the special set of LBC, that is Hamming code and typical example for the LBC, that is linear block code. For the Hamming code, the D mean begin the 3, that is D mean equal to 3 on there for a Hamming code. Due to the reason of this D mean equal to 3, this type of code can detect dmin minus of 1, dmin minus of 1. That means 3 minus of 1 which is equal to 2. So at the 2-bit position, if there any error is occurred, that time it can able to detect, and the number of error correct will be dmin minus 1 by of 2. That means 2 by of 2 which is equal to 1. So 1 bit position error it can correct also. So in the next line it is given to you, that is they are capable of correcting up to 1 bit of error. If the minimum distance of a LBC is 3, then the smallest number of column of H which are linearly depend is 3. Thus, no two columns of H matrix should be identical. So this is the important point also for the Hamming code. And the number of row in H matrix is n minus of k, where the H, again just repeat that, H is depend as a parity generator matrix. For the parity generator matrix, their number of row will be n minus of k, and thus there can be distinct non-zero column, and which is will be value as a 2 to the power of n minus of k minus of 1. Also, the number of distinct column required in matrix H is as value of n. Thus, to have a proper single bit error correction, we should have to total possible number of distinct combination is n minus of 1 k tuple. That means that n minus of k types of formation will be defined as distinct combination, and which is the possible one also, and which should be at least equal to n. So if we conclude in here, so n, that is the code word length, it should be less than or equal to the value of 2 to the power of n minus of k minus of 1, or it can also write down in such way, that is n should be less than equal to of 2 to the power of m minus of 1, where m is defined n minus of k. So if you conclude the property, or if you characteristic the Hamming code, that time these are the characteristic for an Hamming code. There should be code word length, that is n, it should be to the power of m minus of 1. There should be message signal k which is equal to 2 to the power of m minus of 1, and the redundancy bit or parity bit will be m, and which is equal to n minus of k, and d min, that is the Hamming distance, minimum Hamming distance will be equal to 3, and the how many number of bit can be correct on there, it should be equal to 1 on there. So we just pass through a example for our simplification of this total kind of information as a single type of question, and the question is given that design a single error correcting Hamming code for a message length of 4. That means you have to given that t is equal to 1, and their message length, that is k, is given to as a 4, which is also represent at the first line, that is the given t is equal to 1, correcting bit is 1, and k is equal to 4 on their message signal. Now from this you can also identify by using the relation for the k is equal to, for this one relation, so you just write down in this position. So k is equal to 2 to the power of m minus of m minus of 1. If you put the value for the k is equal to as a 4, due to the reason of that message length is given to you as a 4. So if you apply 4 in this position for the k, that time after simplification you got that small m is equal to 3. So if you know the value of m, that means this is defined the redundancy bit or the parity bit for that particular matrix or message. So from here you can also got the value for the n, because the formula is given with relation with the n and m is n equal to 2 to the power of m minus of 1. So if in here m equal to 3, so n equal to 2 to the power of 3 minus of 1, that is its value will be as a 7. So this is a LBC code with 7 comma of 4, because LBC code is defined as a n comma of k in this formation. So we just calculate n as a value of 7, so this is 7, and k already given to you, and that is the 4. So this is 7 comma 4 of bit, and we are considering here the t equal to 1, and d mean also it is defined as a 3. So this is a Hamming code also. To find the parity check matrix, now we are interested to identify the parity check matrix, that is capital H. We are interested to identify this one. To get this one, we have to pass float with this. Consider the generator general form, that is we just consider this one formation, because we know that generator matrix is equal to parity transverse with also the identity matrix. This is the P transverse, and this is identity matrix. Identity matrix, it should be as a n minus of k row and column, that is in here n minus of k, or which is equal to also as a small m, is 3. So identity matrix, it will be 3 cross of 3, 3 cross of 3. So if it is a 3 cross of 3 identity matrix, it can be written down as such, that is the 1 0 0 0 1 0 0 0 1. Now the remaining part you have to identify, that is the P transverse. The remaining 4 column of H, why I am talking about the remaining 4 column? Because for the H matrix their number of column will be n. So we already calculate that n is equal to 7, and we use there for the identity matrix as a column of 3. So remain will be 7 minus of 3, that is the 4. So remain here 4 number of column of each matrix can be obtained from the unused non-zero combination. For the 4 combination, which are the unknown, which are the non-used on there, which one is already used? Because we know that for the n minus of k, for the n minus of k, This is n is 7, k is the 4. So this is 3. So n minus of k tuple, that is the 3 number of bit position the tuple. What will be the value on there? This is will be represented as a starting 0 0 0, then 0 0 1 0 1 0 0 1 1 1 0 1 1 1 0, and then 1 1 1. I think 1 is missing on there, and just this is 1 0 0. This one is missed one there. So for the first, when we are talking about the Hamming code, that time we already told that the non-zero element will be considered. If each and every bit is equal to 0, then you should be obsolete. So this one will be not required. And now you have to check which one is used to generate the H matrix for the column 1. We already for the first row for the identity matrix use as this one, that is the 1 we use there as a value of 1 0 0 due to the reason of this one. Now for the second one is 0 1 0, so we also use that 0 1 0, and for the last row for the identity matrix is used on there 0 0 1, so this one. So which are not used on there, that is the unused non-zero combinations are 0 1 1 1 0 1 1 1 0 and triple 1, and for this reason in this position it is given to you, that is here the unused combination for the n tuple is 0 1 1 1 0 1 1 1 0 and triple 1 on there. Therefore, one possible parity check matrix would be what? You just arrange this one which is not used, that one, as a form of column 1 individually on there. For the first is 0 1 1, so you just apply the first for the parity transverse as a 0 1 1, and then second one value is the 1 0 1, so you can use for the second one as a 1 0 1. In such a way you can complete the parity check matrix, that is H. If you able to know the value of for the H, that time you can generate the G also. How can you generate this one? By transversing the parity P transverse. That is, if you transverse the P transverse, that time you can got this one. So what will be the column for the 0 1 1? It will be write down as 0. Then second one also same way, and such a way ultimately you got the value for the parity matrix, and the uh, identity matrix will be there as the IK. This is the I of K matrix. So for the IK matrix, K is already known by you, that is the 4. So this will be the 4 cross 4 matrix will be there. So this is the identity matrix. So after all, we can got the value for the generator matrix as a Z from the condition which is given in the question. So this is the way by which you can able to identify a LBC, and especially in here for the Hamming code, what will be the generator matrix. So I think each and everyone can able to understand what is the way by which for the Hamming code generator matrix can create. And next day I think each and everyone can come with the new topic. Until I have to say good day and bye.